In this video, we're going to be talking about polynomial division and then the remainder and factor theorems. So let's go ahead and get started. First of all, we need to discuss dividing polynomials. So when we do that, we're actually going to use the same procedure, or what we're doing is much like what we do when we do a long division problem. So if you were doing this problem here, 124 divided by 5, at least in the United States, the way we normally would teach this is you would divide 124 by 5, and we'd write it this way. And then we'd ask ourselves, how many times does 5 go into 1? It doesn't. How many times does 5 go into 12? It goes 2 times. And now that 2 goes right above the 2 there, since we were dividing 5 into 12. When you do long division, it's important that everything gets lined up just right. So once you get the 2 there, the next thing you do is multiply the 2 times the 5, and you get 10. Next, you want to subtract. 12 minus 10 is 2. Then we bring down the 4, and we do it again. We say, okay, how many times does 5 go into 24? Well, that would be 4 times. 4 times 5 is 20, so that goes there. And we subtract, and we get 4. Now, once this number at the bottom here, once we get a number that's smaller than our divisor, which is 5 here, we're done. And so our answer here is 24 with a remainder of 4. When we first started doing long division, this is how we would write our answers. But then we got a little bit more sophisticated, and we would write them this way. This would be 24 and 4/5, the remainder over the divisor. Now, just to kind of set things up for what we're going to be seeing down below, we could write this as 24 plus 4/5. Just think about it. If you were using a recipe that called for 1½ cups of flour, you would put in a cup, and then you'd put in a ½ cup. So 24 and 4/5 here is the same as 24 plus 4/5. Now, before we go any further, there's some terminology I want to remind you of. The 5 here is what we call the divisor. The answer to our division problem is the quotient. And of course, at the bottom here, we have a remainder. Now, these are the 3 most important ones, but there is another number here. The 124 is what we actually call the dividend. All right, so now if you looked over here at our answer, it's in the form quotient plus remainder over divisor. All right, so now let's do polynomial division. Let's look at number 1. So we're going to start, I need to finish out what I was doing up here. There's actually a way to check this. Now, if you were dividing 24 by 3, you would get 8. We know that if 24 divided by 3 is 8, then 8 times 3 should equal 24, since multiplication and division are opposites. So similarly, we could check this one here. We would multiply our divisor, or I should say our dividend, would equal our divisor times the quotient, or the answer we got, plus the remainder. So again, I want you to see the form here, because it's going to be helpful down below. We have dividend equals divisor times quotient plus remainder. All right, so let's go ahead and move on to number 1 now. So we're going to set it up very similar to the way that we did long division with just regular numbers. Now, this first step, how many times does x minus 5 go into x squared minus 8x plus 15? I don't know. You can't really know just by looking at it. But what we can do is a little modification. We can look at these first terms, the x and the x squared, and we can ask ourselves what times x gives you x squared. And of course that would be x. And so we're going to go ahead and put the x right above the x term. Again, the way we line things up is very important when we're doing polynomial division. So we're going to be very careful with that. So now what we want to do is multiply this x times our divisor, x minus 5. So we're multiplying x times x minus 5. Notice we're going to have to distribute here. So you end up with x squared minus 5x. And just like in the problem up above, we're going to subtract this from what's above. So notice we have an x squared minus an x squared. That's 0. Our first term should always be 0. And then we have a minus 8x minus a negative 5x. Well, that becomes plus 5x. So we've got to use that negative for each term. We're basically distributing here. So negative 8x plus 5x is negative 3x. And then we'll bring down the plus 15. So notice there's a plus in there. And we start again. So again, we look at our leading terms here. I'm sorry, I'm looking at the wrong one now. It should be these two. And we ask ourselves, okay, what times x is equal to negative 3x? Well, that would be negative 3, so we'll write minus 3. And then we'll multiply negative 3 times x minus 5. So when you do that distribution, you get negative 3x plus 15. Now when we subtract here, notice we're subtracting something from itself. We're going to get 0. But if you wanted to, you could do negative 3 minus a negative 3x. That's going to be 0 plus 3x. And then 15 minus 15 is 0. So we do get 0 here. So notice the answer we got up here, that's our answer. The quotient there is x minus 3. Now the other thing I want to point out here is just like up above, or similar to what was up above, we could easily check this. If x squared minus 8x plus 15 divided by x minus 5 is equal to x minus 3, then we should be able to write x squared minus 8x plus 15 as the product of x minus 5 and x minus 3. And if you wanted to check it, it does work. All right, let's move on to number 2. So I would actually encourage you to try to see if you can follow the same process on number 2 and then check my answer. All right, so you should have set it up like this. So now we're looking at our leading terms, and we want to know how many times does 3x, or what times 3x gives you 6x cubed. And that would be 2x squared, which would go there. Now another way you could do that is just do 6x cubed over 3x. And notice that does give you the 2x squared. All right, so don't forget, next step we want to multiply the 2x squared times 3x minus 2. You're going to have to distribute. 2x squared times 3x is 6x cubed, and a 2x squared times a minus 2 is minus 4x squared. We'll subtract from what's above. We have 6x cubed minus 6x cubed, which is 0. And again, be careful here. It's negative 16x squared minus a negative 4x squared. That becomes plus 4x squared. Negative 16 and 4, we're going to get negative 12x squared. You got to be really careful when you do this step in these problems. And then let's bring down our 17x, and we do it again. So look at our leading terms. What times 3x gives you negative 12x squared? Again, if you wanted to, you could write negative 12x squared over 3x, and you should get negative 4x. And so negative 4x times 3x is going to give us negative 12x squared. Let's go ahead and multiply negative 4x times our divisor, 3x minus 2. So we get negative 12x squared and a plus 8x. So again, we'll subtract from what's above. And when we do that here, notice negative 12x squared, we're going to get plus 12x squared. That's 0. 17x minus 8x gives you 9x. And let's bring down our 6. And then notice our leading terms, we've got to see how many times, or what times 3x gives us 9x. And of course, that would be 3. And then when you distribute here 3 times 3x minus 2, you'll get 9x minus 6. Now be careful here. This is not a remainder of 0. It's close. When we subtract, 9x minus 9x is 0. And 6 minus a negative 6, that becomes 6 plus 6, and you get 12. So our answer here is the quotient we got. Oh, let's see, before I... Hold on just a second. I need to go back and erase this here because I need that area. All right, so just as a reminder from what we did up above, our answer will have the form quotient plus remainder over divisor. So our answer, or oops, wrong button. Let's do this one here. Our quotient is 2x squared minus 4x plus 3 plus our remainder, which is 12, over what we were dividing by, our divisor, 3x minus 2. Now I just want to warn you, when you're doing the problems in this book, this is the way we normally write answers, but they're having you just tell them the quotient and the remainder, so you may have to write your answers this way. So just be prepared for that. Okay, let's move on to synthetic division. So before we go on, look at these problems. Look at all the x's. There's a lot of writing involved, especially, number 2 as we get bigger polynomials. So there's a way to make this a lot easier. Particularly in both of these cases, notice what we're dividing by, x minus 5, which is a linear expression because it's x to the first power. Oops, let me fix this. And same thing over here, we have 3x to the first power. Although with this one, normally we don't use our shortcut because of the 3 here, but we can talk more about that later. So when we're dividing by linear terms, especially when we have a 1x, we can use a shortcut. Whoops, I'm sorry, I didn't finish writing this out. I just wanted to mention one last thing here on number 2. Don't forget to check it. Our dividend should equal our divisor times our quotient plus our remainder. And so 6x cubed minus 16x squared plus 17x plus 6 should equal 3x minus 2, our divisor, times our quotient, 2x squared minus 4x plus 3, plus our remainder. And if you wanted to check it, you can see that that's true. Now I'm doing these checks because it's going to lead to something in a little bit. All right, let's move on to synthetic division. So again, the key is, this is going to be a shortcut, but the key is these are linear divisors that we're dividing by, and they're going to have a coefficient for the x term of 1. These are the types of problems where we can use synthetic division quite easily. So basically, if you look back, one of the reasons why we don't like division a whole lot, long division that is we repeatedly do divisions and subtractions, which are not our favorites. We'd much rather multiply and add. So what we're going to do here is we're going to eliminate all the x's, and when I divide by x plus 1, I'm going to change the sign, and instead of a plus 1, I'm going to use a minus 1. And by doing that, instead of doing divisions and subtractions, we'll be doing multiplications and additions. All right, so the way we set this up is we take the coefficients of this of our dividend. So that would be 1, 4, and 3. Then we draw a line below that. And the first thing we do is we bring down the first term, the 1 there. Now notice I put the x squared and the x up above. Sometimes people like to do that to remind themselves what those numbers go with. They're just the coefficients of those x terms. All right, so then we do what I call the multiply add cheer. So you may remember being in football games in high school and the cheerleaders would just go crazy and get the crowd going and all that. Well, we're going to do a little bit of a cheer here. We're going to do the multiply add cheer. Probably won't be as much fun, but just remember, multiply, add, multiply, add. That's what we're going to do here. So first we're going to multiply the 1 times negative 1, and we'll put that in right be under the 4 there. And then we're going to add 4 minus 1, which is 3. And then again, we'll multiply these numbers, and we get negative 3, and that goes here. And then we add, and we get 0. So basically, anytime we're using this number, we're multiplying with one of these numbers here. And when we're in a column, we always add. All right, so you'll get this pretty quickly. It just takes a little bit of practice. After a few problems, normally students get it pretty well. Now keep in mind here, we're dividing a quadratic polynomial, degree is 2, by a linear polynomial which has a degree of 1. And so what happens is in our answer, the degree tends to drop, well, it's always going to drop by 1. And so this 1 here is going to be representing the coefficient of x. Again, going from x squared, we're dropping down 1 to x. So this will be x plus 3. The other thing you'll find is that this number should always be your constant in your final answer. If it's not, there's something wrong. All right. And the other thing I want to mention here is since we had a remainder of 0, we've actually found a way to factor this. Our check would be to see that x squared plus 4x plus 3 is equal to x plus 1 times x plus 3. All right, let's move on to number 4. Now, notice there is no x squared term. And don't forget, with division, it's really important that everything's spaced just right. And you may remember having to put zeros in when you do long division, depending on the situation. And that's what we're going to have to do here. We need to have a 0 in the x squared column. And so when we set this up, we'll put negative 2 in the box. And then our coefficients will be 1, 0, negative 7, and negative 4. Let's go ahead and bring down our 1. And then we'll do our multiply add here. So multiply 1 and negative 2, you get negative 2. Add 0 and negative 2, you get negative 2. Multiply the negative 2's, you get 4. Add here, you get negative 3. So again, in the columns, we always add. And then negative 2 times negative 3, we get 6. And when we add, we get, whoops, that shouldn't be negative 2. That should be positive 2. Let me fix that. Let's see. So 2 there. And let's move on. So now our answer here, again, notice this is cubic. And so since we're dividing by a linear polynomial or binomial, our degree will drop 1. So this will be a 1x squared. We have minus 2x minus 3 plus our remainder, which is, and let me fix that again, this is just supposed to be positive 2, over our divisor, which was x plus 2. And I do want to mention in the book, they'll say, hey, what's the quotient? That would be the x squared minus 2x minus 3, and the remainder would be 2. Again, let me fix that. All right. So either of these answers are okay, like on a test. Normally I'll just have you do the division, and that's how you write your answer, the one on the left. But if they ask for the quotient and the remainder, that's how you would write it. All right, let's move on to number 5. In fact, I'd encourage you to try 5 and 6 and then watch the video. All right, so on number 5, oh shoot, I forgot about on number 4, the check. If you wanted to check this, it should equal our divisor, which was x plus 2, times the quotient, or the answer we got, plus our remainder, which should be plus 2. All right, let's move on to 5 now. So we're going to put negative 3 in the box. Notice we don't have an x squared term, so I'm going to go ahead and put 0x squared. you're going to need a 0 in that x squared column. So again, now if you forget to do that, your answer will be wrong. So it's really important that you watch out for that. So the coefficients, let's see, we got 2, 7, 0, 1, and 30. Let's go ahead and bring down the 2. All right, so multiply, we get -6. Add, you get 1. Multiply, you get -3. Add, you get -3. Multiply, you get 9. Add, you get 10. 10 times -3 is -30. Add, you get 0. So again, we got a remainder of 0. What we're seeing with these is we are basically, we've discovered a new way to factor. If we get a remainder of 0, we're going to be able to factor the dividend. So in fact, here you could write, well actually let's write our answer here. Again, since we started with the 4th degree polynomial, we're dropping that down by 1. So that's 2x cubed plus 1x squared minus 3x plus 10. And again, if you wanted to check that, that should equal x plus 3, our divisor, times the answer we got. All right, so on number 6, you should have put, well, first of all, there's a 0 that goes for the x term, and you should have used 4 in the box. Setting it up, you should have 3, -2, 0, -1, 50 as your coefficients. Let's drop the 3, and so we'll do our multiply add here. Multiply 3 times 4, you get 12. When you add, you get 10. Multiply, you get 40. When you add, you get 40. Multiply, you get 160. When you add, you get 10. All right, so in this case, our answer here is going to be 3x squared plus 10x plus 40. Again, remember that number should always be our constant, plus our remainder, which is 10, over what we were dividing by. Now again, if in the book or in my math lab you're asked to write the quotient and remainder, there's your quotient and your remainder is 10. All right, and I'm going to go ahead and stop the video here and I'll do a second part.